Everyone, this lesson comes from the second part of Chapter 9 in Algebra 2. We're still continuing with our topic of polynomials. And today's lesson, really, I don't have a better name for it than Fun with Quadratic Polynomials, because it's really kind of a hodgepodge of different types of problems you might encounter at some point in your mathematical journey. But they all end up looking like a quadratic at some point. So on that note, I did make a note here that you want to make sure you have the quadratic formula program on your calculator, because with all of these problems, or many of these problems, you're going to do a whole bunch of math that's going to be really long and drawn out on your paper, and then you're going to condense everything, and suddenly you'll be looking at a quadratic equation that needs to be solved. And my hope is when you get to that point, that's the easy part, because that can go straight into a calculator. I'd hate for you to have to do the quadratic formula by hand on every one of these. Okay? So, looking at this first one, if you kind of just go with your instincts and think about what needs to be done here, probably you would start doing a whole bunch of FOIL. And you will notice that you've got like pluses and minuses here, so we're going to keep all of those things separate. Okay, so we're going to like FOIL all of these together. So with this first one, and I'm going to take some shortcuts here because I think you guys are pretty good with FOIL now. So that'd be x squared, and then I'm going to end up with a negative 1x and a negative 1x, so that's really a minus 2x. And then negative 1 is plus 1. Plus, and then here I'm going to end up with x squared. I'll have a negative 4x and a 3x, so that's going to leave me with a negative 1x. And then 3 times negative 4 is negative 12. Minus, and notice that after I use this minus sign right here, I opened a set of parentheses because I want to make sure that that minus sign gets shared with everything here. So here we have 2x times x is 2x squared. And then I'm going to end up with a 4x plus a 3x, so that's 7x. And then 3 times 2 is 6. And we have that equal to 3. Okay. So now what I want to do is take that negative sign and distribute it. And so I'm actually going to take the time to rewrite the whole thing here. So I end up with x squared, let's see, plus 1 plus x squared minus, notice all of this is staying the same. Here's where things are going to change. So now I'm going to have a negative 2x squared, a negative 7x, and a negative 6. So I made sure that that negative went to each one of these pieces. Okay. All right, so now I'm going to just start combining like terms, okay? And so let's see, I have an x squared plus another x squared, and then minus a 2x squared. So that's kind of convenient because actually all three of those, whoops, didn't mean to cross out that one, this one and this one, those all cancel out. Okay, sorry, I still have a 2x here. Okay, then I have a negative 2x and a negative 1x, so that has me at negative 3x, and then minus a 7x, so far I'm at a negative 10x. And then I have a plus 1 and a minus 12, so that's negative 11, and then negative 11 minus 6 is negative 17, equals 3 on the other side. And the nice thing about this one, remember I mentioned that a lot of these are going to end up as quadratics. This one did not because those x squareds dropped out. So I very easily could have ended up with an x squared term here. I didn't. And that means I can just solve this thing like a regular equation. So I'm going to add the 17 to the other side, and I'm going to get negative 10x equals 20. And then I'm going to divide by the negative 10, and I end up with x equals negative 2 as a final answer. And you could take that negative 2 and plug it back in up here and check and make sure it works. But it should. Mathematically, it worked out okay. So there's our answer for that first example. Okay, that second one is a little simpler, right? There's not a whole lot of math that needs to be done, but I can tell that I'm going to need the quadratic formula because I have an x squared and an x sitting here. So in order to use the quadratic formula, and when I say quadratic formula, I mean the program on my calculator, I need to move the 30 over to the other side. So I'm going to make this x squared minus 2x. And then if I subtract 30, I have minus 35 equals 0. And so if I go straight into my calculator, by the way, in the next couple days, we're going to talk about a way to use factoring to solve this. We haven't quite covered that yet, although you may have last year. So if you know how to factor that, that might even be quicker. I'm going to hit Program on my calculator, and I'm going to choose the one that says Quad. I'm trying to make it so you can see it here. This program is not my favorite. It's just kind of lengthy. Okay, so I hit Enter a bunch of times until I got to this A equals question mark. My A is 1 because that's what's in front here, right? My B is -2, and my C is -35. And then it should spit out that I have two different roots. You see x1 and x2 with this rounded decimal. You don't really need the point zeros there, but your answer should be 7 and -5. So x equals 7 or x equals -5. Those would be your final answers here. Okay, so sometimes you're going to just be doing quadratic formula. Okay, let's do some word problems. I know we love our word problems here. So write an equation to represent each of the following situations, then use the equations to solve. It is going to be important that you get used to writing the equations here. Sometimes I have some friends who like to guess and check their way through these, and I mean, if it were an SAT question or something, if that works for you, great. But really, the purpose of what we're doing right now is to learn how to write the equations. So this says a number and a square of that number. So I'm going to use x to represent the number, and then the square of that number would be represented with x squared. Add up to 42. So add up, I know I'm going to be adding. So my equation is going to look like this. X plus x squared has to equal 42. So once again, I'm looking at something that has an x squared and an x in it, just like I was up here. That means I'm going to need quadratic formula. Okay? And again, I mean from my calculator. So I'm going to rearrange my equation so that the x squared is first. And then I'm also going to move the 42 to the other side. So that would be minus 42 equals 0. And then I'm going to use my program on my calculator. Now, if you still have the one up from previously, you should just be able to hit Enter and get the whole program to start over again. So again, if you have this version of the program, you have to hit Enter here, you have to hit Enter here. Okay. There is a simpler version of this formula, by the way, and I do have a handout that shows you how to type it into your calculator if you want to program it yourself. Don't forget that you've got ones here and here. So my A is 1, my B is 1, and my C is -42. Again, sorry about my screen. It's my last calculator left. So I have x1 equals 6 and x2 equals -7. So x could equal 6 or x could equal -7. Now, in this problem, there's really no limitations on whether x can be positive or negative or whatever, because it just is a number, right? And a number can be anything. If this were something involving like area or perimeter or something like that, it's possible that that negative answer wouldn't have made sense, and then we would have just crossed it out and ignored it. Okay, so let's keep going. This time we're working with two different numbers, so this I'm going to incorporate x and y. And sum means add. So my first equation here is x plus y equals 28. This is actually going to be a system of equations. The sum of the squares of the two numbers is 490. So sum of the squares means I'm going to square the x and square the y and add them together and have it equal 490. And then we have to find the two numbers. Well, I think the easiest way to solve something like this is going to be with substitution. So what I'm going to do is I'm going to take this top equation and I'm going to rewrite it so that one of the letters is by itself. It really doesn't matter which one. I'll go with y because I feel like that's what we use most often. So if I move the x over, I get this relationship, y equals 28 minus x. And then I'm going to take that value and plug it in right here for y. So now I have this equation to work with. X squared plus 28 minus x squared equals 490. Just a reminder to you that this expression right here with the square really means to do 28 minus x times 28 minus x. So we have to do like FOIL. So we end up with x squared, let's see, 28 times 28, I don't know that one, 784. looks like. And then I'm going to have minus 28x and minus 28x, so that's minus 56x. And then negative x times negative x gives me a positive x squared. And now let's put some things together, and I also can see, just from here, that I'm going to, again, end up with a quadratic formula problem, right? Because I've got x squareds in here, I've got just a regular x in here. I'm going to need quadratic formula. So while I'm doing this, I'm going to go ahead and put together, I'm going to put them in the right order for quadratic formula. So 2x squared, and then I'm going to do my minus 56x. And then I've got the 784, but I'm also going to move the 490 over with the 784. So 784 minus 490 leaves me with 294. Okay. And then I'm going to do quadratic formula from the calculator. So program, quad, enter, enter, enter. So many enters. Okay, my A here is 2, my B is negative 56, and my C is 294. And I end up with 21 and 7. Okay, so here's the thing that's kind of unique about this problem, okay? I came out with two different answers here. Technically, at this point, what I should have to do is plug this back in for x and find y, right? But if I plug in 21 for x, I'm going to find 7 as my y value. And if I plug 7 in for x, I'm going to find 21 as my y value. So really what I did right here is I just found the two numbers because there wasn't anything specifying which number was which. Okay, so my two numbers are just 21 and 7. In another situation, you may have had to plug that back in and solve for the y, but they both came out as answers to my quadratic here. Okay, because really if I had done this whole thing with x by itself here, this whole process would have worked out exactly the same, but just with a y instead of an x. Okay,